We are going to cover the rest of chapter 5. And so on here, we already covered the first three of chemical equations, balancing chemical equations, and recognizing type of reactions. So in this one, we are going to go over redox reactions. Okay, this is going to be the topic. I'm going to break it into smaller videos this time so that we can focus on this and understand each of them better. Okay, so for redox reactions, this one has to do all with oxidation and reduction. Okay, and so that's why we call it redox, reduction and oxidation. Okay, now what does oxidation stand for? So oxidation is the loss of one or more electrons, and then reduction is the gain of one or more electrons. So we saw before that we had those ions, some of them gained electrons, some of them lost electrons. So in this one, we're looking at reactions and we're looking at where the electrons are moved. Okay, either one atom loses electrons or one gains one. And so that's what we're looking at on oxidation and reduction. And then I really like this acronym. So this is oil rig. And this is the way that I remember that oxidation is loss of electrons, and then reduction is gain of electrons. Okay, so I really like oil rig. I'll be talking about that all the time just because otherwise I can't remember which one's which. So if you see me pausing and thinking oil rig, that is why. So on here, one of the first things that we need to do is be able to assign oxidation numbers. So this is a number that indicates whether the atom is neutral, electron rich, or electron poor. So it is a way to track electron ownership and transfer. So this one is going to be very similar to when we used to assign charges. Okay, it's a similar concept. However, this one has different rules so that we can tell which one is gaining or losing electrons in a molecule. Okay, so as we said, it is similar to ionic charge, except we use it for covalent compounds as well. And so that's where we had to make more rules because of those covalent compounds. If it was all ionic bonds, it would be quite a bit more simple. Okay, so how to assign oxidation numbers? Here are some of the rules. So for any neutral element in a standard state of oxidation, the number is 0. Okay, so these ones are actually, oops, let's see. These ones are actually my favorite because 0 is pretty easy to tell. So if anything is neutral or by itself, it's going to be 0. Okay, second rule, for any ion or ions in in an ionic compound, the oxidation number is the charge of the ion. Okay. Number 3, the sum of oxidation numbers in any molecule or atomic ion must be equal to the overall charge of that molecule or atomic or polyatomic ion. And lastly, for covalent compounds, use the following assignments in exactly this order. So this one's kind of nice because we're going to follow this order. So when we assign ionic numbers, we're first going to go with hydrogen. So this one we assign first. And then if we're not sure which one's next, we go with fluorine, then oxygen, chlorine, and bromine, and iodine. Okay, so that's going to help us be able to know when to assign and how to assign. So we're going to see how all of these rules work. So the first one is how, for any neutral element in its standard state, the oxidation number is 0. Okay, so when we see something in an equation, sometimes it'll be just by itself. So like Na, it might even have Na, oops, not. And so that means that it's in standard state. So that's going to have an oxidation number of 0. Okay, if something's bound to itself, like H2, then it's also 0. Okay, and so these are the examples of when an element or atom has an oxidation number of 0. Now let's look at this when it's applied to a chemical reaction. So here we have a chemical reaction. We have two Fe3, FeCl3, and the products are going to be 2Fe and 2Cl2. Oh, 3Cl2. Okay. So if we look here, we see Fe is all by itself. So the oxidation number for this is actually going to be 0. Okay? And then over here, we see that Cl is bound to itself. And so this one is also going to have an oxidation number of 0. So that's how you're going to apply these. If you see a reaction and you have an element that's by itself or an element bound to itself, the oxidation numbers are 0. Now let's look at the reactants. Okay, so I have Cl3 here. Okay, but since it's bound to another molecule, it's going to have an oxidation number. And the oxidation number matches the charge it usually has. So on the periodic table, it's in column 7. It's missing, or it has 7 valence electrons, so it needs one more. So it's typically going to have a charge of -1. Okay, and then let's not forget there's 3 of them. So for Fe, Fe is a transition metal, so we can't know right off the bat what value it has. Instead, we'll look at Cl. Let's see that it has a -1 charge. There's 3 of them, so in total, that's -3. Okay, so -3 on the Cls. Okay, so Fe has to be a +3 to be able to balance that charge. So +3. Okay, so that's how we're going to tell what our oxidation numbers are. And that's how we apply this any neutral element in its standard state. The oxidation number is 0. Okay, let's go to the second one. So on this one, it says for any ion or ions in the ionic compound, the oxidation number is the charge of the ion. Okay, so here I can see Ca has a charge of +2, Cl has a charge -1, okay, because that's typically what their charge is going to be. Okay, but now here on this reaction, we have Na, and this one's in standard state. And so because it's by itself, it's going to have a charge of 0. Cl is bounded to itself, so it's going to have a charge 0. And then when it's bound together, we have plus and -1. +1, -1. Okay, but now let's say I had Na plus Cl negative goes to NaCl. Okay, now the oxidation numbers would be different because now this is an ion. So because it's an ion, it's going to have the same charge as its ion. So it's going to be plus. Cl has that negative charge, so it's going to be -1. Okay, and so that's how we apply this rule. Okay, for any ion in an ionic compound, the oxidation number is the charge of the ion. So if we see a charge, that's going to match the atom. Okay, now, next one is the sum of oxidation numbers in any molecule or polyatomic ion must equal the total overall charge of that molecule or polyatomic ion. Okay, so on this one here, we have CO3, 2 negative. And over here, we have that CO2. So we have to take this charge into account whenever we are trying to balance. So on the first one, on this one, we see that there is no charge. It's actually neutral. So whatever we have in the end must have a neutral charge. So let's start assigning our oxidation numbers. So O2, oxygen is going to have that -2 charge. We can get that by looking at the periodic table. Now there's 2 of them. So don't forget that. Which means for carbon, we have to have a +4. Okay, now on the second one, we look at this, we have CO3, 2 negative. Okay, so this 2 negative we have to take into account. But let's look at how we do that. So first we look at the carbon, or the oxygens. Okay, so the oxygens each have a -2 charge. So in total, they're going to have -6. Okay, however, we do see that this molecule has to have -2 in the end. So how are we going to get -2 out of this? So we know it needs to be added to something. Okay, so because we have to have a positive charge on the second molecule, and whatever we add to it has to equal -2. So it has to be 4. So my oxidation value for carbon is 4. Okay, so -6 plus 4 equals -2. And so that's how we are going to use our charges to be able to solve what our oxidation numbers are. Okay, last rule. So this is the order in which we are going to assign things. So as you see here, oxygen has a very high, is very high on this list, so it's typically going to be one of the ones that's assigned first. And then the main other thing is hydrogen, always assign that first. And then other than that, halogens. Halogens are typically assigned first. Now, why does this matter? This matters because things like carbon, nitrogen, carbon can be plus or minus 4. So we need to know when it's going to be plus and when it's going to be minus. So following these rules, we can see whenever carbon is bound to any of these ones, it's probably going to be a negative. And so that helps us to be able to know how to assign carbon. Nitrogen as well can be +3, or it can be can be -3 or +5. So this also helps me to know which one it's going to be. So now let's apply this rule. Okay, so over here, firstly, let's look at this one. These ones are my favorite because they're so easy to assign. It's an oxygen bound to itself, so it's going to have an oxidation value of 0. Okay, now let's go to the ones that are a little bit trickier. So over here, I have this oxygen, and I'm going to put it as -2 because it's higher on this priority list, and so we're going to assign it first. So as we can see here, I have 2 of them. So in total, I'm going to have -4 as the charge. So to be able to balance that out, I only have 1 sulfur, so it has to be a +4 charge. Okay, +4. Now I look at the other side. Over here, I have oxygen again. Oxygen is going to be -2, but now there are 3 of them. So that's a -6 charge in total. Okay, and then the total charge of this atom is 0. So I have to think of a number that's going to be able to balance that out. So sulfur now has to be a +6. So we get a +6 oxidation number. Okay, so a lot of times with some of them, we're not going to know the charge right off the bat. Instead, we have to assign the one that has the higher priority and then assign the oxidation value. Okay, so watch out for these ones. Okay, so now we have this example. We're going to first look and see, we're going to assign oxidation numbers. Okay, and then we're going to see which one is well, actually, let's just assign oxidation numbers. I think that would be best. Okay, so I'm going to start with my easy ones. I like doing the easy ones first. So carbon by itself is 0. Fe by itself is 0. Okay, now let's go to the trickier ones. So over here I have oxygen. So oxygen is always going to be -2. And so because there's 3 of them, that brings me to a -6. Okay, and I know that the total charge on this is going to be 0 because it's neutral. There's no plus or minus on the molecule. So now I have two Fe's. Okay, so I'm going to put something times 2. Okay, and it has to be able to balance out to 0. So it has to be 3. So I have a plus 3 charge on top of Fe. Okay, now let's go over here. I have oxygen again. Oxygen is going to be -2. Now there's 2 of them. Okay, so I have -4 in total. I know I need to balance it out to be 0. That means I have to have 4, +4 to be able to balance out that -4. So these are going to be my oxidation numbers. Okay, so as we see here, we got them right. I have that +3, -2, 0, 0, +4, -2. So that's good. Okay, but now we're going to have to start talking about oxidation and reduction. We learned how to assign numbers. We learned to see if the atoms have more or less electrons or how many they have. And so now we need to assign loss and gain of electrons. So how we do that is we look at the oxidation number of the product versus the oxidation number the of the reactant. So over here I can see I had I negative, so it has a -1 charge, so it has an oxidation number of -1. And then over here in the products, I can see it's by itself, so it has an oxidation number of 0. So if I go from -1 to 0, I gained 2 electrons, and I gained 2 electrons because of the coefficient in front. So it gained electrons, it's oxidized. Okay. Now on the opposite side, I have the Br. This has a charge of 0. Okay. Charge 0. It becomes a charge of -1, so oxidation number of -1. So if I go from 0 to -1, that means that I gained electrons. Oil rig. Hold on. Okay, good. Oil rig, it's gaining electrons, thus it's reduced. Okay, so that's going to be our next goal. We need to be able to assign oxidation numbers to each of the atoms in the molecules. And then secondly, we want to see if it gained or lost electrons. So let's look at these ones. Let's do some examples. I feel like the best way to learn these is through examples. So let's walk through a couple. So on this first one, I'm going to assign the easy ones first. So 0 and 0, because they're by themselves, because the Cl is bound to itself, so they have a 0 charge. Now let's go back over here and let's see. So Cl is a halogen, it has a high priority. It's always going to be -1. Okay, and then there's 3 of them. So we need to balance out that charge. So Fe has to be +3 to be able to balance out the negative charges. Okay, good. So now let's write them each separately. So Fe on the reactant side was a +3. And now it goes to Fe0. So I can see at the beginning it was +3, so it had less electrons, and now it's a 0 on the product side. So this one actually gained electrons. Okay, now for chlorine, chlorine started as a -1, and it goes to 0. Okay, so before it had an extra electron, now it has a neutral amount of electrons, so it's going to be reduced. No, it's going to be, sorry, it lost electrons. Okay, so now I look at this. If I gained electrons, then that means it was a reduction. So reduction. Okay, now on the other side, oops, I lost electrons. So lost means that it's oxidized. So oxidation. Okay. So that's how we're going to go about assigning oxidation reduction. So let's do the next one. So on here, I have 0 for Na of oxidation value. For Cl, I have 0 as well because it's bound to itself. So on the product side, now I have Na, which has a positive charge, and Cl, which has a -1. And both of those numbers I got from the PR table. Na is column 1, has a charge of 1. Cl is in column 7, thus has a charge of -1. So now let's match these up. So Na starts with an oxidation value of 0, and then in the products it has an oxidation value of +1. Cl starts at 0, and then it goes to Cl -1. So Na, we can tell because it went from 0 to plus, it lost electrons. Okay. Cl went from 0 to -1, so it gained electrons. Now, if I lost electrons, and I look at my oil rig, I lost electrons, so that's going to be oxidation. And then on this one, since I gained electrons, that's going to be reduction. Okay, so now, last thing that we need to learn. The substance that gives up an electron and causes the reduction is a reducing agent. Okay. Whereas the substance that gains an electron and causes the oxidation is the oxidizing agent. So on this one, whatever is oxidized causes something to be reduced. So that's why we call it the reducing agent. So on this example here, we can tell, let me hurry and sign the oxidation numbers. 1 plus 3. Okay, so we can see that the oxidation numbers were +3, -1, 0, 0. So iron went from +3 to 0. So it gained electrons. Okay, so because it gained electrons, it's reduced. Okay, it's reduced. And anything that's reduced is called the oxidizing agent. So for me, I get confused if I think about it in a certain way. So what I do is I always assign, is it reduced or oxidized? Okay, that's what I do first. And then, depending on that, then I assign, okay, so it's reduced, thus it's the oxidizing agent. And that way, I don't get myself as confused. Okay, so just find a way that works best for you, and then stick with it. And that's the end of redox reactions. Now give the worksheet a shot. On this one, it's a lot more trying problems and working it out, being able to assign those values, and then looking at oil rig. So give the worksheet a shot and let me know if you have any questions, okay?